We finally did it. We made our own tool changer for our CNC router and increased the tool capacity by 240%. Our ShopSabre router has always been really good to us, but we've always had two problems. Dust collection is subpar, and the 5-tool changer rack has never been enough tools. Now, to be fair to ShopSabre, they offer a solution to both of these things, a 5-tool rack upgrade, so then we could have 10. And we did consider this, but it didn't solve the other main problem, which was dust collection. And they also offer a solution to this, which is a dust boot system that's an add-on. But in my mind, that add-on is a band-aid and doesn't fix the problem, which is the original tool rack. We are maximizers, and I felt we had a good concept to improve the design and even come out with more tool capacity than was offered. With the tool rack redesigned, we can then fix the dust collection problem. And now that we have this shiny new CNC mill, we can knock out whatever we needed for hardware between our machines. Let's go through the project from CAD design in Fusion 360 to machining these aluminum pedestals on the mill and installing it on the router. Spoiler, it works amazing. There's no surprise that we used Fusion 360 for CAD and CAM. We used models of tool holders, the spindle, and the machine, and then designed our new pedestals and tool forks. That let us quickly switch into Fusion 360 CAM and test our parts. A quick aside, if you're looking to learn Fusion, try our series on the card here. It's free and you can make pretty much anything with it. A couple of items we wanted to change on our version of the tool rack was making each upright as minimal as we could to allow for a tighter dust collection boot and move the suction closer to the spindle. Minimize the tool fork area for the same reasons. Cutting a slot in the center of the pedestal made sense so you could see the tool easily. Make openings in the phenolic to allow longer tools, and made it modular so we can swap out a damaged one or upgrade if we have a new revision to make. We went through a few versions, but we landed on 3 pedestals per unit as an easy enough size to make on the mill, and it solved all of our problems. Design work for a project like this is tough unless you have accurate to life models. Much of our friction getting started in this project was just modeling and confirming the machine as is. You don't want to go drilling through into the steel of the frame on accident. With the parts designed, we can jump into CAM and then start making these parts on the mill. But first, how about a few Fusion 360 tips that I found helpful while working on this project? Design using components, this is nothing new, but they let you check them out or edit so you can work concurrently with another user. That worked really well here. I would be editing, say, the tool fork, and Andy was editing the pedestals, and we could sync them up together, no problem. Use real hardware and models. McMaster plugin is fantastic for this. If you haven't tried it yet, you can import a step file straight into your Fusion file without even leaving Fusion. Here's a quick cap head screw I downloaded as a step file straight into Fusion. Don't be afraid to start over when the model gets messy or you have another idea. That's pretty much our policy at Portland CNC is you make a first model, it's probably going to be junk, and you start over whenever you need to. Don't try to save it. Next, CAM and Fusion 360 for the pedestals and tool forks. The pedestals are made from 6061 aluminum. I won't walk through the CAM here, but there are 4 setups to each of the pedestals. You have to flip back and forth quite a few times to reach everything, and we wanted to put chamfers on because that just looks nice and you don't cut yourself. In setting up our work holding for the mill, we had this Kurt Vise and actually bought a second one. And Kurt, like a lot of other work holding companies, let you download their models, and so then we made that into a parametric model, which makes your setups pretty fast, so you keep it in its own file here, and then copy it and rename it, and then insert your part file into that model. Inside of there, we have the stock set up already, and then you can insert your part. That's the drive part there, and then you just joint it where you want it to be. So the part is jointed to the stock up here, so then you can obviously set your work coordinate system wherever you want here, whatever makes sense for you. I think we set it on the left right there. To quickly edit this, depending on what your part is, so most of that's driven by stock here. So the parallels can be adjusted too, and that's also a joint. Oop. So if I wanted those to sit a little lower, set them at 0.75, stock X. Pretty easy to change here. Stock Y will actually change the jaw opening, as you can see there. This is really pretty easy to do. It's just making some joints, and then you need to work with components, and that makes your setup really smooth too. So you can save inside of your Vise model here. This is the container system of Rob Lockwood's creation. You keep your work holding all ready to go, and then your setup is already set up in a way in manufacturing that it already has the vise as the fixture, and your stock is set up already as the stock. And so the container, if you will, is the component, and those things are already there. When you open up a new model, you've copied it, and then you can put your part inside that component if it works out for you. And basically you can go from having a work holding setup, if you need this to be accurate, to, quickly change the setup to what your stock and part looks like, and joint in your part, and you're ready to go. So jump back into ours. We just copied the vise, and then it uses a lot of the same parameters to drive that, and that way we can have an accurate representation and not run our cam into those vise, obviously. I'll make our parametric vise available on our website and on our Patreon, of course. Look for that video article link in the description. Got this aluminum stock up with our Evo saw, which has done okay, but seems to have some quality issues. I think a metal bandsaw is in our future. If you have one that you like, let me know. Gotta say, it's definitely nice having 20 tools at our disposal in the YCM, and obviously we'll have a lot more in the router soon here. This was a big project for us to get comfortable making parts in the YCM. So far, we're incredibly happy with its finishes. We've mostly been using Maritool tooling. The YCM is a Fanuc control, and while that's nice for documentation, it's sort of like the Windows of controllers. I also hate it. It has this archaic feeling while using it. For example, you need to hit roughly 12 buttons in a specific sequence to copy a file to internal memory. And oh, the memory. All 512 kilobytes, which is hilariously small for any kind of contemporary trochoidal adaptive toolpath. I'm new to this kind of machine, and I know it's incredibly common, but our next machine will not necessitate using a damn compact flash or USB stick to transfer files to it. Alright, well, I got that Fanuc rant out of the way. The YCM has been stellar for us so far. The pedestal parts are big enough that it felt like two vices made for better holding. Luckily, we picked up a second 6-inch Kurt when we bought the mill, and it's coming in handy. The first operation removes a bunch of material. We start off with the Maritool face mill first. It cuts phenomenally well, but you're probably not going to see it because it creates a cloud of coolant. Good thing we got a mist collector. So this is the first time we tried to film inside the mill, and immediately you see it getting covered. There's a GoPro inside a waterproof case, and we've got one of those air jet blast things that we just haven't hooked up or 3D printed the little part for yet. So it did pretty well, and you can see kind of what's going on there. The only mildly concerning thing about this machine is when the spindle ramps up in the low gear, it makes this weird noise, and we're not sure if that's normal or not. Probably going to have a tech come look at it. It happens right after this. Sounds odd, right? This machine only has like 300 hours. Who knows? This is an adaptive clearing tool path with a 375 3-flute Maritool rougher. Got it in a shrink fit tool holder, which is pretty fun. That's our first shrink fit. And no, we didn't buy a shrinker, we just used the torch. Coolant's pretty great at what it does, but it also sucks for filming. Let's jump ahead here in this tool path. I'm still getting used to how fast this thing rapids. It's like 1G acceleration. Did a little more time warp to the end. Now for the 3/8 3-flute finisher. Coming from mostly running the router with an 18-second tool change, this feels insanely fast to me. We can run this finishing pass without the coolant, just using a little bit of air blast so you can actually see what's going on. Could have probably run this at full depth, but it was 2 passes, and it's 11,000 RPMs at 80 inches a minute. Still trying to find the best way to shoot this, but I was pretty happy with this shot going through the polycarbonate window on the side. You can actually see what's going on. Final depth cleanup here. This is basically all of the finishing operations for the sides. We won't do that on the other operations. Now, change my mind. There's nothing really better than a good chamfer toolpath. I mean, come on. It's just gorgeous. Call me simple, but I just had to let that really roll out. I love watching chamfers. We won't go through every setup in this detail, but I thought that it was easily the best of all of them. Let's flip it over for op 2. Starting out op 2, we flipped the part over, we've decked it with the face mill, and now we're using that 3/8 rougher again. It takes quite a bit, and there's really not a lot to see because the coolant's just kind of going everywhere. So we'll probably skip through a bunch of this, but know that it happened. Right about now, we kill the GoPro on accident.
8 hours later.
Finished up that roughing. That took quite a while. Most of the operation. The face mill here is going to clean up the surfaces, make them look nice and shiny. The next tool is the 3/8 inch finisher. I'm going to clean up these vertical walls. And that little bit of the floor that the face mill couldn't get. There's one more chamfer operation here, but you already saw it. I didn't get it in focus for some reason. That's alright, we already saw a bunch of chamfering. Let's go to op 3. And we got the part flipped in this funky looking setup, but it's to drill the holes into the bottom of the part. And we're going to do that with this 1/4 inch rougher. We tried to do it with just a little bit of air blast, and well, this project wasn't without failure at times, so you're going to see it chip weld real fast here. Well, we actually stopped it and saved it right before it did, but you can see, no dice. We got those holes bored off camera with some coolant, and we flipped to a 1/4 inch finisher just to remount those holes to proper diameter. Turns out you won't chip load if you're just cutting out maybe a couple thou with just air. There's probably a way to do it. We just haven't figured out how. So if you have good tips on cutting without coolant for filming's sake, let us know what we're doing wrong here. You probably can't tell from this view, but those are through holes. They're not blind. So looking back, I probably would put the tool all the way through and then just do a little revolution to clean it up instead of this bore from the top. This is a cute little cut to clean up the corners that were just rough step before.
No, you're 100% right.
little more of the tasty chamfering. As I believe Grimswell once said, chamfer everything on the machine, and I agree with that. Alright, I won't play all of the chamfering, even though it's my favorite part. For the last op, you might have guessed it, but the part gets flipped 180, and then we drill into the top, and honestly, it didn't film well. We had to use coolant, obviously, for some deeper holes, and we had some issues tapping, but we got those parts made, and we'll show you how we install it next. This is our first major project with the mill, and I was pretty stoked about how these parts turned out. Now, over to the ShopSabre so we can install these new ATC pedestals. Didn't take much to take off the old ATC rack. It had 4 bolts on it, and those were quick to take off. So our solution here is to infill the previous hole with some acetal, and then face that down to the thickness so that we have a nice flat surface. We'll also have to take off some of the phenolic and make it nice and flush with the existing surface. So we're going to use this shear hog for maybe tools to do that. Not gonna lie, most of this process was pretty nerve-wracking. It's not every day you cut into the bed of your router. It feels cannibalistic. Contact. Relief. Release a little of the feed. Now we've cut quite a bit of acetal, so this is nothing new, but I'll really want that to be nice and flush with the phenolic at the end. Made a little miscalculation on this setup, and so you can see at the end I wasn't getting all of the stock, so I had to set that up again and do a little air skimming there until we caught back up. Definitely wanted to check to make sure we weren't going too far, so we wanted to face the acetal just to the top of the rough phenolic, which is the table surface. Ooh, yeah, very flat. One of our concerns here is we were holding down the acetal with some 1/4-20 hex bolts, so we had to stop and take those out, grind down the heads a little bit so we didn't hit them, and then put them back in to finish up the facing. And the part I was dreading, facing the phenolic. I mean, basically all the steps up till now are reversible, so get this wrong and you end up replacing some pretty expensive material. But as you can hear, it started out really nicely. This is 12,000 RPMs, 90 inches a minute, and about a 3/4 inch step over. Very intentionally leaving a little bit so we could really fine tune and flush up the transition from the existing surface to the new surface. This isn't cutting area, but this is where the new pedestals will go, and we just wanted it to be a nice, smooth transition between the old and the new surface. There's an interesting amount of deviation in the mill surface on the right here versus the left, where we had already surfaced and had come from the factory. So we took our time and measured it out to make sure we got it really nice and flush. And by careful, I mean there was a lot of 1 and 2 thou step downs till we got it just right. By the way, doesn't smell great. Should definitely wear a respirator and probably not do this often. Scratch. Sniff. Yep, that's the one.
Pretty good. Almost no edge.
The OSO scientific finger scratch test. Seems to pass muster. Finally, let's let this go and surface it out at the proper height. This is actually a pretty good example of why we want to improve the dust collection. It just doesn't seal or get the suction close enough to the spindle, so you have lots of excess just draining out. Unfortunately, I estimated a little too far and we hit the back of the table, so I had to go change the cam and make our final cut a little bit less. So now I have to live with that reminder of that edge not being perfectly flush. Now that we've flushed up the table, we're going to do some spot drilling, and we just used a normal HSS drill for that. Probably should have gotten a spot drill. Didn't have one, so we used a normal split point. Another reason for doing the spot drilling was to make sure that all of our new mounting locations weren't going to hit anything, and there were where we wanted one, and a spot drill is a lot less than an actual hole into the table. And now the real thing, the same HSS drill, but in for the real full drilling experience. Didn't take long to pick up a few strings. Got quite the nest going there, but didn't seem to affect anything, so we kept going. Please disregard the spinning 2-2 of chips. It's actually working just fine. We're pretty stoked about getting this far, so next up Andy went to town on tapping all these holes. There's quite a few of them. Gorgeous work, only 71 more to go. And now what may be the biggest pucker factor of this whole thing for me was cutting extension holes through the table. Everybody had gone home on a Friday night. It's about 6:30, and I decided, let's go for it. If I stop now, I'm not going to do it right away on Monday. Then everybody's going to be waiting around, so we just cut through the table. And by we, I mean just Justin, by himself, weary on a Friday night. But hey, it went just fine. I used a hem operation to really cut through it fast, but the first initial slotting after the ramp would take off so quick, so I was sitting there manning the feed control of ramping it way down to like 40% until it got through the slot, and then I'd let it go. Also sucking out the dust until I realized it was just dropping through the floor, which is a new experience because you're cutting through the table, obviously. To actually cut this deep into the table, we had to get a new ISO 30 ER16 that's about 100 millimeters of tool holder length, and then using a 3/8 two-flute up cutter, we could cut through the table, which was kind of a weird experience for sure. So this definitely took a bit, and it was definitely nerve-wracking, but totally worth it because now we can have tools that are roughly 10 inches long outside of the tool holder. That's not something we use very often, but we were limited before, especially when making like our iMac bases. That limited the height of those because we could only tool change to about 4 1/8 inch, I believe, outside the tool holder. Since we really maximized the whole table with our new tool positions, the last and the first can't go all the way through. The phenolic has obviously run into some steel for the frame there, so they go deeper, but not all the way. So now you can imagine I was pretty stoked to try these out and see how they fit. We were ecstatic to find out that they fit perfectly, almost exactly perfect alignment all the way across. And some of that had to do with the pins we used for alignment rather than just using the tapped holes. Definitely give credit to both machine makers here that both parts came together flawlessly, and we gave no extra slop to the dowel pin holes, and the ShopSabre drilled those perfectly on the spot. I didn't really talk about these till now, but we did redesign the tool forks and make those ourselves too. So those fit pretty perfectly, and they do work great with the tool holders. We did also make them have a positive location so they don't wander like they tended to do in the past. Assembling these pedestals and forks was really, honestly, pretty fun. It went super smooth and really didn't take that long at all to get it all set up. The only thing left at this point was to dial in each new tool position, which is pretty easy using WinCNC. You just kind of step through the tool change position and then set a position. I suppose that's not totally true. There were some other settings to change, but it wasn't hard. I almost forgot, we also made a new pedestal for the Z probe since it used to be connected to the old rack, and that's on the left side. We even got fancy with a little engraving. Now, adding capacity to this machine is amazing, like sort of a dream for how long I've used it and how much I've wanted it, but I have to say there are a few moments that make you happier as a business owner than a team of people hustling to make something. I have moments every once in a while, like this one, where I just stand back and go, damn, we really have some great people who care about what they do. We used all of our tools, and I don't think we could have done it without the collective thought and effort of everyone here. That's mushy, but I really do mean it. Now, there's another big improvement to be made still. We are finishing up our design for the new dust collection interface. Right now we think we can put the volume of a 5 to 6 inch dust port much closer to the spindle. Currently the only option is a 4-inch port, and that really isn't enough. Our new pedestal design allows us to use a handful of different lengths of dust skirt and have no issues changing tools, which is pretty big. I'll definitely be posting more videos about this, especially the dust collection, as we progress, so subscribe if you haven't already. If you're interested in this project, let us know in the short interest form linked in the description if you'd be interested in possibly buying our tool pedestals or the upcoming dust collection interface. We are thinking of selling them. Hope you enjoyed watching this. I had fun making it. And until next time, I'm Justin, and I play a machinist on YouTube. If you want to support the channel but don't want a Patreon-like subscription, Buy Me a Coffee is the perfect option. The idea of Buy Me a Coffee is to offer someone a cash equivalent of buying them a drink as a thank you. It's a one-time thing to show your support for the channel and keeps the content and coffee flowing. Look for the link below for Buy Me a Coffee. If you want to get our CAD and CAM models that we show in the videos, subscribe to our Patreon at cnc.money. Thanks.
If you haven't subscribed, it's imperative you do. I know if you watched this far, you obviously enjoyed it a little.